So we were discussing about diagonal. So what is a diagonal? A line segment joining non-adjacent vertices of a polygon is called a diagonal. So how can we find a polygon will have how many diagonals? Let us say, for example, in a triangle, can we draw any diagonal? No, we have just discussed it. In a quadrilateral, how many diagonals do we have? We have 2 diagonals. Now, if I say in a hexagon, how many diagonals will be there? You will have to worry, you will have to think. So, there is a formula to find number of diagonals in a polygon. And what is the formula? The formula is n into n minus 3 by 2. Now, let us where n is the number of sides of the polygon. So, for example, if we take triangle, in a triangle, n is how much here? N is 3. So, if I put here 3 into 3 minus 3. 3 into 3 minus 3 by 2. So this gives us how much? 3 into 0 by 2 is 0. So you can see, and you know also that a triangle does not have any diagonal. Let us check for quadrilateral. So here n is 4. So how many diagonals will it have? 4 into 4 minus 3 by 2. So 4 into 1 by 2 we can cancel. So how much you are getting? 2. And you know that in a quadrilateral we have 2 diagonals. So it is proved. So this is the formula to find number of diagonals in a polygon. So I asked you a question, how many diagonals will a hexagon have? Hexagon has how many sides? 6 sides. So if I take n is equal to 6, so how many diagonals will it have? 6 into 6 minus 3 by 2. So that gives us 6 into 3 by 2. So 3. So 9. So how many diagonals will a hexagon have? It will have 9 diagonals. Clear? Okay. So this you don't have to write down. You just need to write down the formula which I have already given in the notes, the formula, and the exercise is there. In the exercise you will get sums where you will have to find number of diagonals where sides n will be given. Now next point which we are going to discuss is convex polygon and concave polygon. Convex and concave polygons. Now in these two names you might have come across in your physics topic. Okay, here in maths, then how does we refer to convex and concave polygon? See, I'll draw some polygons here. Now here children, if you see this, oh, I have drawn it the same manner. Let me draw a quadrilateral. Here you see, if you observe, what do you observe? That the angles, I have drawn 5 sides. Let me make it as straight. Yes. So here, if you observe the angles, children, what do you observe? You see, all the angles, this angle is less than 180 degree, this angle is less than 180, this is less than 180, this is less than 180. Do you agree? If I join the diagonals, it lies inside the polygon. Here you see the angles. Look at the angles. All the angles you see are less than 180 degree, right? So, and the diagonals if I draw, you know how to draw the diagonals, isn't it? We have discussed already in our previous topic. All the diagonals are lying inside. Now, so how do we describe a convex polygon? A polygon in which none of its angles is more than than 180 degree and the diagonal lies in the interior of the figure. You all know the meaning of interior, exterior and on the figure. Suppose I have this figure. This portion is what? Interior, this is exterior, and if I draw something on this boundary, it will be on the figure. So, convex polygon is a polygon where none of its angles is more than 180 degree and the diagonals lies inside the polygon. Then what is a concave polygon? Children, let us look at this shape. This is a what? It's a quadrilateral because it is made up of 4 line segments. But you observe the interior angles. We are talking about the interior angles. This is less than 180. This is less than 180. This is less than 180. But what about this? This is more than 180 degree. So, a polygon whose at least one angle, if it is more than 180 degree, then that polygon is called a concave polygon. Clear? Now, what about the diagonals? You see here, diagonals, the definition does not change. That line segment joining non-adjacent vertices. So here, this and this angle are non-adjacent. So if I join these two vertex, this is a diagonal. This and vertex and this vertex, they are non-adjacent vertex. So if I join them, where is the diagonal line? The diagonal is lying outside the figure. So in a concave polygon, one angle, at least one angle should be more than 180 degree, and in that figure, one of the diagonals will be lying in the exterior of the figure. That is called as a concave polygon. I hope I am clear. Okay. So this is convex and concave polygon. Now let us talk about another type of polygon, that is a regular polygon. You have heard the word regular in 6 also, 7 also. What is a regular polygon? Regular. Regular polygon. A polygon whose all sides and all angles are equal is called a regular polygon. So can you give an example of a regular polygon? Equilateral triangle is a regular polygon because its all 3 sides are equal and all the angles, all the 3 angles are equal. Then in quadrilateral, which is a regular polygon? Did anyone say a rhombus? Rhombus, all sides are equal, but it is not a regular polygon because the angles are not equal. So which is a regular quadrilateral? Square is a regular quadrilateral because all its sides are equal and each angle measures 90 degree. So we have discussed concave polygon, convex polygon and regular polygon. Clear all of you? Now let us discuss about irregular polygon. So what will be an irregular polygon? Irregular polygon, a polygon whose all sides and all angles are not equal is called as an irregular polygon. Clear? So concave, convex, regular, irregular polygon we have discussed. Now you all know that the sum of 3 angles of a triangle is 180 degree, and how that you have done in class 6 as an activity, that if you draw a triangle and you cut out the 3 angles and if you paste it on a straight line, it will completely cover the straight line at a point. That means it will cover 180 degree. So with the activity also we concluded that the sum of three angles of a triangle is 180 degree. For quadrilateral, you know that we have not done an activity. In 8th, we will do the activity that sum of four angles of a quadrilateral is 360 degree. How can we show it, students? You see here, if I draw a quadrilateral and I draw a diagonal, let us label it A, B, C, D. Now, if I label it 1, 2, 3. So, in triangle ABC, angle 1 plus angle 2 plus angle 3 is how much? 180 degree. Do you agree? 2 plus angle 3 is 180 degree. Why? Angle sum property. And here let us label it 4, 5, 6. And in triangle ADC, what do you get? Angle 4 plus angle 5 plus angle 6 is 180 degree, again by angle sum property. Now, let us write this as equation 1 and 2. If you add this to equation, what do you get? Angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 is equal to 180 degree plus 180 degree. Now, angle 1 and angle 6, can you see they are lying together here in the figure? So, let us bring these two angles together. Angle 1 plus angle 6. Then, let us leave angle 2 as it is. Then again 3 and 4, we are combining it together. And angle 5, let us leave it. And this is how much? 360 degree. Do you agree? Yes. Okay. Now, angle 1 plus angle 6 is what according to the figure? Angle A plus angle 2 is angle B plus angle 3 plus 4 is angle C and angle 5 is angle D. That is equal to 360 degrees. So, you have proved that sum of four angles of a triangle is, four angle of a quadrilateral is 360 degree. So, this way also we can do, and we will do it as an activity also. So, we have seen here, but then if I ask you what is the angle sum of a hexagon, that is the sum of all the angles of a hexagon, will you keep doing like this? No, I'll discuss this in my next module. Thank you.